All right, everybody. Welcome back to another day of notes and a new unit of notes. So this unit, we used to call it 1B. We're technically calling this Unit 2 now. And Unit 2 is going to be right up there at the top as either A, the most difficult unit that we have, or B, the second most difficult unit that we do. Now, I'm hoping that if we get everything that we need to done and accomplish this unit, that it makes the other unit that I'm referring to much easier. And that unit is stoichiometry. So if you've ever talked to a student from chemistry, maybe a junior or senior, or maybe you have an older sibling, they may tell you that stoichiometry was the most difficult thing that we did the entire year in chemistry. Now, hopefully if we get everything down this unit, stoichiometry will be a breeze. But with that said, we have several topics that we'll be going over, and please do not panic about how big this packet is. I know you see there's 8 pages of notes in total, but we're only doing half of them today. The following class, we'll do 1 additional page, and then that final class, we will finish up the notes. So we're going to do half of these notes here today. And we're starting off with just the basics. We're doing measurements on this page, along with some units. We're going to talk about reading equipment and how that's going to be done. And then the most difficult thing that you're going to learn today is Sig Figs. You've probably heard the term Sig Figs and not known what it stands for. It stands for significant figures. And this is all based on mathematical type things. So with that said, we're going to go ahead and start with the first couple pages of notes. And there is a PowerPoint posted, and I'm actually looking at the PowerPoint just to make sure I get everything filled in here correctly. But anyway, we're going to start off with the basic units that we have, which is the simplest form of a unit, okay? Or simplest single unit that we could have is what I should say. So the simplest single unit for a measurement, which could be anything like grams, seconds, meters, what else? Liters. It's just a basic single unit. Now, if you're in pre-AP, you really have to have a great grasp of what a derived unit is. In on-level, all we do really is talk about it. But it's a unit that comes from multiple other units that have been combined. So multiple units combined is what a derived unit is. And you're going to see some of that as we get down to these bottom two. Volume can have derived units. Those are derived. And as well as density. Density is always derived. Because what derived is it's a combination of units. So volume, if you ever see like cubic centimeters, which you're probably used to that. Cubic centimeters, that's centimeters times centimeters times centimeters. So it's 3 things of centimeters. Well, what about density? Density is measured in grams per milliliter. And you won't be expected to have this down pat today, but next class, we're going to work a lot on density. Okay? Today, we're really focusing just on these basic ones like mass. Excuse me. What does mass measure? Well, mass is a measurement of the amount. Amount of what? It's the amount of matter that there is. And then in this column, we'll be filling out what equipment we would use to measure it. And so quite simply, I'll just put a balance, whether that be an electronic balance or a triple beam balance. Some type of balance is what we would use. It can be measured in kilograms or grams, which the symbols for those are really easy. kg for kilograms and just G for grams. All right, now moving on to length. Length basically is a distance measure. It measures the distance between 2 objects or the distance of a single object. And for that, we would use a ruler. You can have meters or centimeters, which would be just M or cm. Now notice everything here is lowercase so far, including the next one. Seconds are lowercase. So sometimes you see it with just an S. You'll also see it SEC as well. But time is basically a measure of just, well, it's really that easy. It's the amount of time that goes by, or time elapsed. And then you can use a stopwatch or some type of timing device. I'll just put timer to measure that. And it's really as simple as that. We also have, now notice everything's been lowercase so far, and this really does matter, guys. In chemistry this year, we've got to make sure we're using the correct letters. So you'll have Kelvin, which is a K. I know y'all are familiar with degrees Celsius, and I'm even going to put on the word Fahrenheit here. And I'm hoping I'm spelling this correctly. But Fahrenheit, we would put degrees F. So notice these are all uppercase letters, and the only one without the degree symbol is the Kelvin. We don't use that for degrees with Kelvin. But temperature is a measure of the, basically it's the movement of particles. A fancy word for that would be average kinetic energy. All right, we use a thermometer to do that. Okay, and that's enough for temperature. So moving on to volume. Volume is the amount of space something takes up. So I'm just going to put amount of space occupied. And I think that'll be a good enough description there. It's the amount of space occupied by something. There's several things we could use. We could use a graduated cylinder. We could technically use a burette, but in on level, I'm just going to leave it at graduated cylinder. You could also use a ruler if you wanted to do length times width times height. If you use a ruler, it's going to give you meters cubed or centimeters cubed. If you use a graduated cylinder, it's going to give you like liters or milliliters. And liters and milliliters are abbreviated like this. And then meters cubed and centimeters cubed would just be like so. Okay, so again, these two are derived units. Density is also going to be a derived unit because density is a combination of mass and volume. It's using both of those. So really right there we can say that density is mass divided by volume, and you will learn this next class. Oh, I was actually supposed to put that right here. So right here what I should have written was the amount of matter, well, mass in a given amount of space for volume. But as long as you know this part, you're golden. So what units would I use for that? If it was grams per milliliter, it's going to look like that. And if it's grams per cubic centimeter, it's going to look like this. Now I will go ahead and make notation here when we use the two different ones, because it's different when you have a solid or a liquid. So we'll touch on this again when we get to density later on in the week. But for right now, just think about it. Milliliters or cubic centimeters, which one sounds more like a liquid? Okay? It's the one that you would use what? The graduated cylinder or the ruler for? I think you can all agree that a graduated cylinder is going to tell us that for a liquid. And then if you're measuring the density of a solid, you would use the cubic centimeters. All right. So moving on to the next page of notes here. This is important to know, guys, because this happens in lab all the time. And the types of questions you'll get on the test, you should be able to tell me which one already. But if you don't know, guys, when y'all get to a lab, and I tell you to measure, like, let's say I tell you to measure 50 milliliters of something. Please don't go try to do that in the beaker or the Erlenmeyer flask, and definitely not this. You would never measure anything in a test tube. So the most precise would be the graduated cylinder. And no, I forgot to answer this. The least precise is definitely the one that I scratched out the most. The test tube is not going to accurately measure anything. Now, why? Well, look at the markings. I don't know if y'all can tell on your copy, but this is 50, that goes to 100, 150, 200, 250, 300. But look at this. It's much more. I can go 10, 20, 30, 40, and all the way up to 100. And then it's got even the little bitty tick marks in between. So that's why I'm going to use this if I want to be really accurate. Okay, now this part is always confusing for students at first, but it deals with measuring recording different measurements. You're always going to estimate all known digits, okay, plus 1, and we'll talk about that in a second. But first off, what are known digits? Well, I know that's 1, 2, 3, 4, but do I know more than just that? Yes. These little ticks, if this is 1, and so I start at 0, from 0 to 1, what are these going to be? Well, that's going to be 0.1, 0.2, 0.3, 0.4, 0.5, and so on. So I know to the nearest 0.1 are my known digits, plus 1 estimated digit. So let's go over this. I'm going to write the answers off to the side here, and we'll get some good practice right here. But if you look at letter A, guys, letter A is a little bit more than 0.5. If all you did was put 0.5, you got it wrong. You have to be, you put the known digits, yes, but did you estimate 1 additional digit? No, because it should have another number after the 5. And don't worry, we're not going to get nitpicky as teachers. I think it's like, I don't know, maybe 0.52 or 0.53. But as long as you're close, you're going to get credit for it. Now let's look at letter B. That tick mark right here would be 0.8. So does it look like it's before the 0.8 or after the 0.8? I think it's slightly before the 0.8, so I'm going to call it 0.79. Oh, and don't forget to put the units. These are centimeters. All right, how about letter C? We've got, it looks like it's after 1.5, but not quite to 1.6. So right here you might say 1.58, or I'll put 1.59 centimeters. But you're going to see this next class when y'all do the laboratory. The laboratory is going to have you measure these and make sure you're being as accurate as possible. Now letter D, I'm glad this one is right smack dab on the line. That line right there is 2.5. But guess what happens is if you choose 2.5 on a quiz or on a test, you got it wrong. You have to put the known digits plus an estimated digit, even if it's a 0. So even if it's a 0, guys, you still got to put it. So that'll be 2.50 centimeters. All right. Same thing here. It looks like letter E is smack dab on whatever that is. I think it's 3.3. But if that's all I put, I got it wrong. It's 3.30 centimeters. All right. Now last is letter F, and it looks like it's not quite to 3.7. So it's going to be 3.68 probably. But again, if you put 3.67 or 3.69, we're not going to fault you for that. So that right there, if you want to label what the estimated digits are, sorry, that's not the estimated. Those are the known digits. And that one right there is my estimated. So you have to do this when using equipment. Now, okay, the glassware has the estimated digits, which are those little, I call them tick marks, but they're technically called divisions. And so if you have like a glassware, graduated cylinder, ruler, something like that, you're going to do exactly that. So you would look at this one and you would say, okay, well, coach, that's between 30 and 40. Well, good. What are the little ones? Well, that's going to be 31, 32, 33, 34, 35, 36. And it looks like it's in between 36 and 37. So you may not remember from middle school, but you always look at the meniscus. Okay? Look at this curve part. Don't look at the side where it touches the side. We want to look right here. So it's in between 36 and 37. But if all I put is 36 or 37, I'm wrong. I have to add one estimated digit. So, I don't know. I'll put this, but you could put 36.5 or 36.7 if you think it's on either side. Now, here's the key part with electronic scales is you do not estimate a digit. So do not estimate. Okay? That 0.0, it just is what it is. There's no need to estimate since you're using something that's electronic. All right, guys, so I'm going to go ahead and pause the video here. This is the halfway point. And then next we will be getting into Sig Figs.